All right, let's talk about something we all want, right? A future powered by clean energy. But, and this is a big but, there's a really surprising paradox right at the heart of this whole green transition. Today, we're going to dig into that very problem and the absolutely revolutionary quantum solution that's being built in labs all over the world to fix it.
So, this green energy paradox, what is it? I mean, before we can even get to the cool quantum stuff, we've got to really wrap our heads around the problem it's designed to solve.
Yeah, it feels completely backward, doesn't it? I mean, you'd think, hey, more solar panels, more wind turbines, that just means more clean power for everybody. Simple. But what's actually happening is it's introducing this whole new level of, well, chaos and complexity that our current grid just wasn't built for. Not even close. Okay, so here's the breakdown. For starters, the sun isn't always shining, right? And the wind doesn't always blow. That creates a super erratic supply. Then you have our battery storage systems, the things that are supposed to smooth all this out. They get totally worn down from the constant stress of charging, discharging, charging, discharging. And the computer programs we're using now to manage the grid, they can't keep up. It's too chaotic. And the result of all this? You get a fragile system, one that's just begging for failures and, yep, blackouts.
But whenever you have a really thorny problem like this, you have innovators looking for a brand new, powerful tool to crack it. And that's exactly where the world of quantum computing steps onto the stage. It offers a totally new playbook for managing our energy. The solution they're working on is called a quantum microgrid. It's basically a mashup of two really powerful ideas. First, you've got microgrids. Think smaller, local power grids that can run on their own. And then you add in the second ingredient, the insane problem-solving power of quantum computing, which, it turns out, is a perfect match for the kind of massive, complicated optimization puzzles that renewables throw at us.
And the difference here is it's night and day. We're talking about going from a brittle, centralized system to something that's resilient and local. Instead of being slow to react when things go wrong, a quantum-enhanced grid could actually be self-healing, adaptive. And get this, where our old system chokes on complexity, this new one practically eats it for breakfast, optimizing everything in real time. So look, this isn't just some theory stuck on a whiteboard anymore. All around the world, countries are setting up what they're calling living labs to actually put these ideas to the test. Let's do a quick world tour and see how it's all shaken out. Okay, first stop, Israel. Their approach zooms in on one of the biggest weak spots in the whole renewable energy chain, the batteries. Their entire strategy is about durability. How do we make this critical hardware last longer? And the result? It's pretty staggering. By using a quantum annealer, which is a type of computer built specifically for these kinds of optimization problems, researchers found the absolute perfect charging patterns to slash battery wear and tear by a whopping 40%. Just think about that. That means batteries that last way longer, are more reliable, and a grid that's a whole lot more stable. All right, now let's hop over to China. Here, the challenge isn't just about one component like a battery. It's about coordinating an entire, vast, complex region. Their focus is all about scale and reliability across a huge network. You could say it's about creating harmony out of chaos. In the Xinjiang region, they're using quantum algorithms to perfectly schedule power from all their solar, wind, and storage. And they're doing it in real time. It's literally about taming the chaotic nature of renewables, but on a massive scale, just to make sure the lights stay on for everyone. Okay, next up, we've got the global quantum computing company D-Wave. They're tackling the problem from a totally different angle, resilience. You know, what happens when the grid suddenly gets hit by a storm or a piece of equipment fails or maybe even a cyber attack? Well, their solution is a really smart hybrid system. It combines the raw, super fast power of quantum computing with the tried and true reliability of classical computers. What this does is it lets grid operators instantly figure out the absolute best way to reroute power and recover from a crisis. We're talking about minimizing downtime, minimizing damage. It's all about being ready for whatever gets thrown at you. And for our last stop, let's head to Germany. Now, this is interesting because their strategy is almost less about the tech itself and more about a philosophy. Their focus is on community and on decentralizing control over energy.
Yeah, this quote really nails it. Germany's project, called Q-Grid, is envisioning a future of what they call energy democracy. Picture this, neighbors trading power from their rooftop solar panels directly with each other. And the quantum computing part? That's what helps manage all these tiny peer-to-peer exchanges, essentially creating a self-organizing grid from the bottom up, not the top down.
Okay, so it's really important to understand that these living labs aren't just isolated science experiments. Not at all. They're basically the proving grounds for competing national strategies in what's becoming a new, very high-stakes global race.
And when you actually lay them all out side by side, you start to see how each approach reflects a deeper national philosophy, right? You've got Israel, laser focused on protecting its critical infrastructure. You have China, all about securing reliability on a massive scale. Germany is pushing to empower local communities. And then you have companies like D-Wave building these resilience tools for the entire global market. So at the end of the day, this goes way beyond just being green. Mastering this technology is now a critical piece of the puzzle for national security, for economic competitiveness, and for geopolitical influence. It's really about achieving what you could call energy sovereignty. So, where is all this heading? Let's take a quick look at what the future of our energy system could actually look like. Over the next decade or so, we can probably expect to see three really big things happen. First, you'll see quantum systems getting integrated with AI to get way better at forecasting energy supply and demand. Second, the development of quantum secure communications to shield these new smart grids from cyber threats. And finally, you're going to see a push for global standards so all these different systems can actually talk to each other and work together. And this, right here, really gets to the core of this new tech race. The countries that figure out how to master this combination of quantum and energy, they won't just be building a better grid. No, they'll be setting the rules for the entire global economic and political landscape for decades to come.
And that really leaves us with a final, pretty big thought. All these projects we've looked at, the ones focused on durability, on scale, on community, and resilience, they're not just experiments anymore. They are full-on dress rehearsals for the future. So the question really isn't if our energy system is going to be transformed. The real question is, who's going to be writing the rules when it happens?